So again, we want to make sure that we can connect percentage with fractions, proportions, uh, ratio, rate. So, and decimal represents what we would consider the unit rate. So if I divide this fraction, I'm going to get 0.625. That 0.625 is a decimal value of that fraction. It also represents our unit rate and our unit percentage, or decimal percentage. But we can convert this into actual percentage by moving that decimal place over 2 places, so we get 62.5%. Okay, so decimal to percentage is fairly straightforward. We move the decimal point over 2 places, so 0.72 becomes 72%. As a fraction, we can write that as 72 out of 100, because a percentage, the decimal percent, we can make it into a percentage out of 100. It does share a common factor. Looks like it shares common factor of 4. So we end up with 18 over 25, okay, as a simplified fraction. So 55% to convert into decimal, we just move the decimal point over 2 places to the left this time. And then we can write this as 55 out of 100, which simplifies to 11 out of 20 as a simplified fraction. Okay, so we could do, want to make sure that we can make this connection fraction, percentage, decimal. Now, this example is shown in the red here. This is using percent as a multiplier. And again, it's really important to make sure that you first of all understand how percentages can be set up in a proportional equation. But you may have noticed in some of the questions that we can use the percent as a multiplier. So in these questions that we did up here, we talked about this a little bit up here, in that if I want to have my percentage as a multiplier, that multiplier is going to be the up and down multiplier. So for example here, the 1 over 5, if I divide 1 by 5 and a multiplier, I can find any multiplier by division. And then that up and down multiplier actually represents our decimal percentage. And we could either times or divide by that multiplier. We had a case here. We're going from top to bottom. Bottom to top is times. Okay, so bottom to top here is times. From top to bottom is divide. So some problems may involve division. So we can use this times divide strategy since percentages are proportional equations and proportions are to do with times and divide. We can use multiplication to solve some of these problems. So we're going to do this as a proportional equation, and we're also going to use another method of just timesing and make sure we understand how that times fits into the proportional equation. So here's a problem here. So we have Jill's playing darts. She hits the dartboard 24 times out of 30. What percentage of her throws did not hit the dartboard? So she missed 6 times out of 30. And we want to know the percentage, so it's going to be some percentage that we're going to solve for out of 30. If I divide these two numbers, okay, I'm going to get 0.2. So there's my up and down multiplier. That up and down multiplier happens to be my up and down multiplier on this side, and it happens to be the decimal percentage. It's not that it happens, it's always the decimal percentage. Okay, that up and down multiplier is my decimal percentage, which is also something we're going to see later as a unit rate. So the percentage that did not hit the dartboard is going to be 20%. Okay, 20% missed the dartboard. So we can solve it like this. We could also solve it this way. Okay, we can say that we have 30. Okay, we have we can say we want out of 100. This is my whole. This is my total, and we can times it by the part, okay, which is 6 miss out of 30 total. And when you go 100 times 6 divided by 30, we're going to end up with 20 out of 100 that's going to be missing. Okay, so this is, we can start using this times on top, divide on bottom, to show that the times and divide can cancel, the total, notice the units, the totals cancel, and we get our miss, the miss percentage when we work this out. So the units tend to work out. And really this is based on times on top, divide on bottom, and the fact that times and divide will cancel each other out. So this is a strategy. I'm just going to put it off to the side here, because this strategy here to the right is something that you're going to end up using much more later on. But for now, we want to really just make sure we're focusing on this proportional equation. Okay, so on a 50 question quiz, Tony scored 88%. So we're going to set up a proportion, 88% out of 100%. It's a ratio comparison, so it's a times and divide relationship. So how many answers did he get right? Well, this is part to whole. This total of 50 questions, and then we want to figure out how many he got right. Okay, so this is going to be my decimal percentage. So I divide 88 divided by 100 gives me 0.88. I'm going to use that same multiplier to solve my problem. So x is equal to 44 questions. Okay, this is 44 questions correct. Now again, I want you to recognize that there is a left and right multiplier, and if you chose to use that one, that's perfectly fine. This is divide by 2. Divide by 2 would also have worked. Okay, we can also use this multiplying strategy. Okay, so we have 50 total, and we have 88 correct out of 100 total. We know that these cancel out, those units cancel out, times on top, divide on bottom, so 50 times 88 is going to give us 4,400. Okay, and we divide by 100, we get 44 correct. Okay, so again, this is a multiplying strategy that is something a little bit new, but this is a strategy that we'll probably eventually start using much more. But for now, we just want to make sure that it's good to understand the right-hand side, but it's very important that you understand the left-hand side and understand the proportional relationship and how it fits into a proportional equation. And then once we make sure we understand that, we can start connecting this idea on the left to this idea on the right. What happened? How does this connect to here? Well, there's my 0.88 multiplier. Okay, that's going from 50 to 44. That's going to be what's going on here. Okay, that's my 0.88 multiplier there. Okay, so if you want a connection, there's where the connection is. So here, Harry receives a raise of 27 cents per hour. This is a 6% raise over his previous salary. What is his previous salary? Well, the 6% represents the raise compared to the total. This is the original salary. And we can say that the 27 cents, I'm going to write that in dollars, so $27.27 is a raise. And we want to find out the total, or the original. Okay, that's my proportion, that's my comparison. Again, remember it's a proportional comparison. I have my multiplier going this way as 0.06. It's times. I want to go in the opposite direction, so I'm going to divide by that 0.06, and I'm going to get x is equal to, I kind of need a calculator for this one, but 0.27 divided by 0.06 gives me $4.50. So 100% is $4.50. Okay, so that's my original hourly rate, or the previous salary. So we can also do this using that same multiplying strategy as before. The 27 cents per hour, okay, this is a raise, and we can multiply that by, well, I really want the 100%, and the 6% is my raise. Okay, so essentially I'm going to divide by the 6%. Okay, and that's going to give me my $4.50. That's my original. Okay, and again, if the units work out, I've done the calculation correctly. Notice that how I flipped that fraction, and now it represents divide. Okay, so it's essentially dividing by 6%. Okay, and there's my divide calculation there. So again, if you want to know the connection, here it is. This is my multiplying factor. Here, in this case, my dividing factor. So this last one here, this is where we have 3%, 3 centimeters represents 2%. So that's my comparison. And what is a new height? Okay, so we can set this up a couple ways. We can say that 3 centimeters, that's my growth over x centimeters total, or my original height, is equal to 2% compared to 100%. Okay, and the 100% represents the original height, then we have to add 3 centimeters to get the new height. So that's one way to do it, but we have to, add on afterwards. Now, my question would be, if this is my 2% to 100%, I'm going to do this, 3 centimeters to x centimeters, and I'm going to do 2% because that's the 3 centimeters should go with the 2%, but I want to find out the total height, the new height. So this is new height. This was the original height. Now, which is perfectly fine. If I solve this proportion, it's a times by, you can maybe see it, it's a times by 50%, or times by 50. Okay, so I'm going to say you can divide times by 0.02 going up, or you can actually times by 50 going down. Okay, there's my decimal percentage again. But the question is, can I make this comparison and say that the new height is 102% and make that a comparison? Is this okay to do? Can I compare percentages that are not 100%? Okay, and can I compare them in a ratio form like this? And the answer to that would be yes. Percentages are all about times and divide. If I compare a percentage in a ratio, that's all compatible mathematics. It's all times and divide math. So this is a perfectly good comparison. This is a proportional comparison of 2% to 102%, and we can solve this directly. So this is times by 51. Okay, and if I times by 51, my new height is 153 centimeters. Okay, and that's the same as I would have gotten here. My original using that times by 50 would be 150 centimeters. Okay, and then I'd add on the 2 centimeters, the 3 centimeters to get my new height. But notice here, this solves for the 102% directly. And that's okay to do, and the mathematics is consistent because I'm putting percentages as a ratio comparison. And I can compare percentages in a ratio, and it's mathematically consistent.